Hello everyone, today I want to teach us use the Excel to solve the Gauss-Seidel and the SOR. But at the SOR we have two methods. One is the provided omega and another one is the omega optimal. Okay, I take this 3 times 3 square metric as our example to teach us how to use the Excel to calculate it. So for the left side we have the Excel. Okay, we focus on the Excel. Okay, the iteration start with 0 and x1 0 also start with 0, x2 also, x3 also. And the error for the iteration 0 is nothing because we doesn't have the number before that, so we take like this. Okay, and okay, so we use the formula to solve this by using the solve this metric by using the Gauss-Seidel first. Okay, right. Okay, everyone look at the column A3. So we took that column A2 plus 1 for us to write as a iterations. And for x1 we see of the word that we already rearranged the formula, so we use the rearrange formula to calculate this. So you see what I said. Open bracket 2 plus x2 divide by 4. Okay, this is our new x1 formula. Then the new x2 formula is 4 plus new x1 and the old x3 divided by 4. Okay, this is our new x2, and the x3 we use the open the bracket, then 10 plus x2 plus slash 4. Okay, this is our new x3. So when we done that, we can find the error. The error is easier. We use equal ABS because we want to find the absolute number. So if our error have negative, it will be positive. Okay, minus before that. Okay, enter. Then we drag it to the right side so we can see all the error. And for the max error is pretty easy. We equal to max, then we take this because we want to see the error where the error will stop, to find the accurate number that where the number is. For the status, how to do that because we want to like ensure where the number we need to stop. And okay, we need to make sure that the max error here must less than 0.0001. We want more accurate. And the value, okay, if the number is less than 0.0001, it will show us stop. Okay, and the next we will say continue. Okay, we highlight this row and drag down. Okay, so we now will got the full formula and the full table for the Gauss-Seidel. So as we can see, the iteration 8 we stop there because our x1, x2 and x3 max error is less than 0.001. Okay, now we're going to use the SOR to calculate these questions. Okay, then we set also same with before, but we plus one things for the omega provided is 1.25, already 1.25. Then okay, we set a new formula for the SOR. Okay, be equal to upper bracket 1 minus omega provided. Then we remember to log it. How to log it? You place F4 to log it. Okay, times this one, time is before, then we plus omega optimal. Remember to log it. Okay, log it, and times. Okay, we use the formula before, x2 dash Okay, we done it. Then we go to the another one. Also 1 minus this, then log it times before plus omega optimal, log it times 4 plus new x1 plus x3 divided by 4. Okay, go to the next one. 1 minus times plus omega optimal, log it times 10 plus x2 divided by 4. Okay, we also find the error. Remember this absolute value. We need to find absolute value. Don't forget it. Okay, drag to the left. And we set to find the max error. And we set a status. We highlight this and drag top. Okay, so we got a new, so we can see the SOR method, but you see the interaction between the Gauss-Seidel and the SOR is quite different, right? Just now I say the SOR will be faster because like the SOR method give you omega which is 1.25, and the Gauss-Seidel also have a SOR, but we doesn't say it because the SOR is 1. Not the SOR, is the omega. The omega of the Gauss-Seidel is 1. So we can say maybe these equations, the omega optimal will more approach 1. So we go to find the omega optimal. So you can see we use the when we find the omega optimal, we will find Jacobian matrix like this one. Okay, so as we can know, we got a matrix A here. So we do that. We key in this, key in all this in the Excel. The formula to find the omega optimal, you just need to find the determinant to find the eigenvalue. So we need to set the formula. Okay, lambda we set as 0 or something else. Okay, it's lambda I, so we need to set the formula I. So okay, it will equal to this matrix minus this matrix times this matrix. Okay, so we can see the new matrix. We will call it C. Okay, how to find the lambda? We go to find the determinant of matrix C. So we need to find the eigenvalue will be equal to 0, so we set to find the determinant first. Okay, determinant for this will be a number. Oh, as we say, when we set 0, we found our determinant is 0. So we can say that we got 3 lambda because you see as formula we got 3 lambda, so this formula got 3 lambda. We find one of the lambda. Okay, with like first one is 0. Okay, then how to find the other one? We go to data, we forecast, we what ifs, we go 6. Okay, set cell, we set this. Oh sorry, I forgot. We change the lambda to a bigger number of the small number. So maybe you can test from 1. Okay, so we go to forecast, go 6. Okay, this number to be 0 by changing this number. Okay, we found one of the lambda here, one of the new lambda. So we write it down. And we go to another one. We set it like -1. This 0 by changing lambda. We come to find another lambda. So how we make sure to know that what the eigenvalue that we need? So we want to find the absolute max. Sorry, it's the max absolute number. So this one. Okay, we see the absolute max number is 0.35554. Then so we calculate the omega optimal here. The omega optimal for the formula is 2 divide open bracket 1 plus square root 1 minus lambda square. So we got omega optimal. So we can copy this. We change the name first. It's very easy. We copy this number to here. Oh sorry, I forgot. We only can copy the number, so we remember that 1.03377. Okay, we write here. So we can see this will stop earlier, so we can delete here. So we can say that three different the iterations. The Gauss-Seidel is not the faster, but it was more stable compared to the SOR with the provided omega. If the omega more near to 0, no near to 1, the number will, the iteration maybe will more suitable to use Gauss-Seidel, but we cannot ensure the omega optimal to find the SOR, so we need to try first lah. So as we can see for these 3 methods, the SOR with the provided with the omega optimal is more faster to the Gauss-Seidel, and the Gauss-Seidel is more faster to the provided. Why SOR more faster to the Gauss-Seidel? Because we use the omega optimal. Then why Gauss-Seidel convert more faster to the omega provided? Because the omega optimal for this question is more near to 1. So we stop here. Thank you everyone, and hopefully everyone can learn something here.